Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have b to the power of 6 equals to 27, and we solve this problem for the values of b. So here you see that this is an equation of order 6. It means that this equation has 6 roots. So now here our target or our claim is to find that 6 root of this equation. Okay, so here first we rewrite this equation as now we write this b to the power of 6 as b square and its whole cubed equals to, we have this is 27, we write this 27 as 3 cubed. Okay, after this step here we need to move this 3 cubed in the left hand side. So we write it as b square and its whole cubed minus, we write it as 3 cubed and this is equals to 0. So after this step here we need to use a nice cubic formula. You know that if we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. So here we need to apply this nice cubic formula to the above this term. So here you see that b square is our a and our b is equals to this 3. Okay, so now according to this formula we write our above equation as in this form. So first we write a minus b. So here our a is b square minus b is 3 into a square. So here our a is b square and its whole square plus ab. So here our again a is b square and b is 3 plus b square. So b is our 3 square and this is equals to 0. Okay, so further here we need more simplifications and we write it as b square minus 3 into, here we write this expression as b square and its whole square equals to b to the power of 4 plus, here you have this is 3 times of b square and plus this 3 square equals to 9 and this whole equation equals to 0. So now in the next step we need to break this equation into the two cases. So our first case is we write b square minus 3 equals to 0, and the second case is we write b to the power of 4 plus 3b square plus 9 equals to 0. Okay, so now in the next step here we first focus on this equation. So now here we need to find the roots of this equation. So that first we rewrite this equation as, first we have b square minus, we write this 3 as square root of 3 and its whole square equals to 0. So here we need to use the nice square identity, and you know that if we have a square minus b square, it is equals to a minus b times of a plus b. Okay, here we apply this nice this algebraic formula in the above term, so that our above term is written as b minus square root of 3 into b plus square root of 3 and this whole equals to 0. So now in the next step we write this into the two cases, so that our first case is we write b minus square root of 3 equals to 0, and the second case is we write b plus square root of 3 equals to 0. So in the first case we easily get the value of b equals to square root of 3, and in the second case we easily get the value of b equals to minus square root of 3. Okay, so finally we have the two values of b are plus minus square root of 3. So these are the first two real values of the given equation. So now in order to find the other values of the given equation, we need to solve our second case. So this is our second case, and here we substitute, or here we will just take that y is equals to b square, and when you take the squaring on both of the sides, then you get y square equals to b to the power of 4. So here we need to substitute these two values to the above equation, so that after substituting these two values, our above equation should be written as this is b to the power of 4, it is equals to y square plus 3 times of b square equals to y, and this is plus 9 equals to 0. So now here this equation will becomes quadratic in y variable, and now here we need to use the quadratic formula in order to solve this equation. So first we write the coefficients of this equation, and its coefficients are a is equals to 1, b equals to 3, and c equals to 9. These are the coefficients of this equation, and now we apply the quadratic formula. It is stated as y equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is the our quadratic formula, and now here now we need to substitute the values of a, b, and c in this nice formula. Okay, so when you substitute the values of b, you will have b equals 3. It will be written as minus 3 plus minus square root of b square. B is 3 square minus 4 times of a is 1 and c is 9, and it is divided by 2 times of a. So here our a is equals to 1. And now in the next step we need more simplification here, and we write it as y equals to minus 3 plus minus square root of 3 square, and 3 square equals to 9 minus 4 times of 9 becomes 36 divided by 2 times of 1 equals to 2. Okay, so further you have we need to subtract these two values. So here we have minus 3 plus minus square root of minus 27. We know that 9 minus 36 equals to minus 27, and it is divided by 2. So here we write this into the simplified form or more lowest form. So we have minus 3 plus minus, we write this 97 as 9 times of 3, and we write the square root of minus 1 here. It is divided by 2. Okay, so further we have y equals to minus 3 plus minus, here you know that square root of 9 equals 3 into square root of 3, and we know that square root of minus 1 equals to iota, and it is divided by 2. Okay, so these are the two values of y. So now here we need to back substitute the value of y, as we have y equals to b square. So we need to substitute this value of y here. It will be written as b square equals to minus 3 plus minus 3 into square root of 3 iota, and it is divided by 2. Okay, so further we need to take a square root on both of the sides of this equation. So when you take the square root, it will be written as in this way. So these 2 and square root are gone, and you get b equals to plus minus square root of minus 3 plus minus 3 into square root of 3 iota, and it is divided by 2. So these are the 4 complex roots of the given equation, and we have the 2 real roots are plus minus square root of 3. So these are the total 6 roots of the given equation, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.